Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrell's Algebra 1 and 2 class. Today we're continuing with logs. So far, logs seem to be pretty understandable. It looks scary. I was actually talking to a student last night, and they say to me, "Oh my God, when I first saw this, I wanted to cry." And I agree. It's a very scary thing. Okay, you look at this and you're saying to yourself, "Oh my goodness, what is going on?" But we already know that it's not that bad. Just as a refresher, log base b of the answer equals the power. This translates into b base to the y power equals x. Okay? Remember that, my friends. Remember also that if I have log base b times b to the x power, the log base b and the b cancel, and I'm left with x. Please remember that if I have b to the log base b of x, this base cancels out that exponent of log b, and I'm left with x. So as long as I have a base that equals the answer, or a base that equals the base of the log, they both cancel, and you're left with x. Yes, sir, my brother. Come again? No, no, this is correct. Oh, the bottom. No, it's not y because the exponent is x. I could have called that x, w, or k, or thank you, my brother, for caring. So now, today we have properties of logs. Good news, guys. This is the last thing that you have to really learn about properties. Tomorrow is just solving equation after equation after equation. So we're not doing that bad. And this is not 7-4, it's 11-4. My bad, sorry. So let's get to it. Product property. Guys, remember what I had told you, that logs are the inverse of exponents, right? Well, their properties work very, very similarly. When you multiply the same base, what do you do to the exponents? Okay. When I have log b of m times n, I can add it as well. This can break up into the log of m plus the log of n. Okay? When you're multiplying products of logs, you can split it up into the log of m plus the log base b of n. Please notice that the base has to be the same for both. So for example, log base 3 of 5 plus log base 3 of 4. I can either expand it or simplify it. In this case, it's already expanded, so I'm going to simplify this. So this is going to be the log base 3 of 5 times 4, or the log base 3 of 20. Does that make sense? How and why I got that? Okay, think about it. When you're adding logs, what does that really mean? That you're multiplying the two values to one log. Does that make sense, son? Thank you. Yes, sir. If I went to re-expand this, remember, that's why I went step by step. If I went to re-expand this, this would be the log base 3 of 5 plus the log base 3 of 4. Thank you, sir. Does that make sense, guys? Okay, quotient rule, same thing. What did you do with exponents when you divided the same base, guys? Well, when you have a division being attached to the log of the same base, you subtract the logs individually. So the log base b of m divided by the log base b of n, okay, equals log base b of m minus log base b of n. For example, if I have the log base 4 of 48 minus the log base 4 of 12, this simplifies into the log base 4 of 48 over 12, which equals the log base 4 of 4. But what does that equal? They cancel, so it equals 1. Does that make sense, guys? And this was wrong. This should have been 4 here, and that should equal 1. Does that make sense, guys? You see the connection here? So if they're being added, you reduce it into multiplication. If they're already being multiplied, you can expand it into addition. If there be 2 logs of the same base are being subtracted, you can combine that into a division. If they're being divided, you can expand that into a subtraction. When I raise a power to a power, what do I do with the powers? I multiply them. This is the one that is the trickiest of all. Okay? If I have log base b of m to the n power, I can simplify this by bringing the n to the front and multiplying the value of n times the value of b of log of base b to multiplying the n times the log base b of m. Do you notice here how this 8 is being multiplied to the log base 3 of 2? I can simplify this by saying log base 3 of 2 to the 8th power. And that would be log base 3 of 2, 4, 8, 16, 32, 64, 128, 256. Does that make sense? Does that make sense? Promise? Okay, because now we're going to practice. Wait, no, last thing. Inverse property. We already learned it, and in fact, I started the lesson with it, right? That's how I started the lesson. If I have a to the log of base a, if these guys are the same, flunk, they cancel, bye-bye, I'm left with x. If I have log base a to the times a to the r power, as long as this base is equal to that answer, this cancels, I'm left with r. So, for example, 3 to the log base 3 of 7, these guys cancel, I'm left with 7. Log base 3 of 3 to the 5th power, these guys cancel, I'm left with 5. Those are the properties. You know these properties, I promise you, tomorrow's lesson, it's not a joke, this is definitely not a joke, but it's going to be very, very simple. Sir. Yes, sir. For the addition. Yes, for the multiplication. Product property. Okay, log base 3. Oh, and they just say of 20? You can expand that a lot of different ways. Yeah. They would usually go the other way. They'd probably tell you log base 3 of 10 plus log base 3 of 2 type thing. Okay? Thank you so much. Why don't we practice some, guys? Is that cool? All right. Thank you, my brothers. So let's write each expression as a single log. So when they want a single log, they're going from expanded form. I'm not trying to be sarcastic, but they're going from expanded to 1 log. What does that mean? Do you see how I have 2 logs here, guys? I want to simplify it into a single log. So if they're being subtracted, where did that come from? Division. So this would be the single log of base 4 of 32 over 2, which equals log base 4 of 16. That's the single log. They did not ask me for the value of that. But just for giggles, what is the value of log base 4 of 16? Doesn't this equal a y, guys? Isn't this what you just did yesterday? You said to me was so easy. Isn't this 4 to the y power equals 16? So doesn't y equal 2? So the value of this is 2. This is the value. I'm not asking for that, but that's what your homework was last night. I wanted to make sure you got this, so please, guys. But all they want when they say single value, that's it. I mean single logarithm, that's it. I may say to you, also give me the value. So you got to know both. Okay, now this one is a great one. 6 times the log base 2 of x plus 5 times the log base 2 of y. You have two different operations here, don't you? You have an exponential operation, and you have an addition operation. Does that make sense? So, what do you think we would do? First of all, what's the log going to be? You've got to make it one single log. So it's going to be the log base 2, right? What does addition mean? Okay, so I'm going to multiply at this point x and y, right? But what does this little 6 mean? It's to the 6th power. So this is log base 2 of x to the 6th times y to the 5th. Does that make sense, guys? This is like huge, guys. You should be so proud of yourself. This is huge stuff. Some people in college don't know how to do this. Okay? Some teachers don't know how to do this. So you should be proud. No offense to any teachers out there, but some teachers just don't teach this level math. So you guys are doing really good stuff. I'm proud of you. Yes, sir. If it has a different base, you're out of luck, Chuck. Like for real. No, I'm not joking. You'd have to find the individual value of that plus the individual value of that using a calculator type thing. Okay? Okay, here, I've got log base 4 of 5x plus log base 4 of 3x. What would this combine into as a single log? Log base 4, good job. 15x squared, I love it. Beautiful. 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 Very nice. If I wrote this like this, could I also have written this like this? No. Thank you very much. If I did it like this, guys, that would imply that I'm affecting the 15 as well. Very, very good job, son. So that's why we don't do it like that. Very nice. That was awesome. Okay, next. 2 log base 4, 6 minus log base 4, 9. What do I got? Tell me. Log base 4 of 36. Thank you, because 6 squared over 9. Beautiful. So this is going to be log base 4 of 4. Oh, I already did this one. And that equals 1. Now, again, technically speaking, this is the answer. Because I asked for a log and a single log. If I said find the value, that would be the one. I just don't want you to think you have to find the value when they say write it as a single log. Single log is single log. I'm just going a little further because I want to just keep practicing that skill. May I continue, gentlemen? Thank you, gentlemen. Now, find each logarithm expanded. Okay, so what's happening here? They're being divided, so that means when I expand them, I subtract them. Good job. Very good job. Log 4x minus log of y. Done. Just out of curiosity, for giggle, what's the base of log when it's straight up like that? 10, yes. Okay, my brothers. B, log base 3, 9, x to the 5th. I'm adding, right? So I'm going to go log base 3 of 9, right? Plus. No, I heard someone say the correct thing. Plus 5 log of x. Now, we're missing one thing here, though. What does that 9 break down to? 3 squared, right? So this would technically be 2 log of 3 plus 5 log of x. That's expanded. You got to expand it all the way. I'm sorry. Sorry. I did not say find the value. If I wanted to find the value, then this would be 1, and it'd be 2 plus 5 log base 3 of x, right? But I did not say find the value, my brothers. Thank you for caring, though. Does that make sense? Okay, let's continue then. Log base 9 of x to the 4th. Whoa. X to the 4th divided by 729. Okay, what am I doing here? Tell me. Talk to me. No. 4 log base 9 of x minus log base 9 729. Now, I know I'm a pain in the butt, but 729, isn't that 81 times 9? So isn't that 9 cubed? Right? So this is 4 log base 9 of x minus 3 log base 9 of 9. I would accept either one, okay? But maybe if you go this way, maybe I'll give you extra credit. I don't know yet. Know how to do both, because the SAT may have them in both forms. So you got to be able to know. Sir, my brother.
The final answer that you get is divisible by the base. And you can simplify, because I'm confused why on top you change the 9 to 3 and then 9 to 29.
Okay, why did I change this 9 to a 3? Because that's 3 squared. 3 squared, I have to expand it. 2, 3 squared. 729, I realize, is 81 times 9, which is 9 cubed. So the 3 out here, 9. Because when I expand it, I've got to apply all of the properties, my brothers. Thank you so much, son. Okay, log base 3 of 250 divided by 337. What do I got? Uh-huh. Okay, now, here's the cruddy part. 250. That's 2 times 125. And that's going to be, well, that's 25 times 10, right? Right? So look, check this out. I know you love me. I know. Log, this would be really log base 3 of, this could be 25 times 10, right? Right? You with me here? And 25 is 5 squared, right? So check this out. This will really be 2 times the log base 3 of 5 plus the log base 3 of 10 minus the log base 3 of 37. Do you see that awesomeness that I just did? It's crazy, I know, but that's part of log. Sir. Okay. 250 is 25 times 10, right? When you have a single log of multiplication, doesn't that break up into addition? Isn't 25 5 squared? When you're expanding your log, doesn't 5 squared mean you have to multiply it in front of the log? So I got 2 times the log of 3, base 3 of 5. That's my 5 squared. Right? Times 10 plus log base 3 of 10 minus log base 3 of 37. I have no idea what you just said. Go ahead and tell me. Write it out for me. No, write it. It may help the whole class. Tell me real quick. Okay, you're talking about this number? That number is only if there was an exponent. The reason why I had that 4 there, okay, is because I had x to the 4th power. The powers come out as a multiplication in front of the log. Division expands to subtraction. Multiplication expands to addition. It's a great question. Thank you. Okay. Good. And I think, okay, one more. Okay. Oh, yeah, this is the fun part. You're going to love this. Calculator time. Logarithms can have many different bases, guys. The log key on your calculator finds log base 10. The and the ln key, we talked about this yesterday, finds log base e of a number. However, you can use the change of base formula to evaluate a log with any base using a scientific calculator. If I give you log of base m, of base b times m, okay, this is going to equal the log of m divided by the log of b. Literally that easy. So it's the log of the answer divided by the log of the base. So it's log of the answer divided by the log of the base. What is this man talking about? What's my answer here for A? 27, right? That's my answer, right? And my 81 is the base, right? So to find this, it's log 27, bless you, over log of 81. Go ahead and put that in the calculator, guys. What do you get? 7.75. Did everyone get that? Did everyone see that? Yes, sir. Log is just, it could be log of any base. But what base are we going to use? We're going to use a calculator? Log of 10. We're going to use log. I could do ln as well. It doesn't matter. You can put the log of any base times the answer over the log of that same base times the base of the original. Log base 5 of 36. This is going to equal log of 36, literally, divided by the log of 5. Literally. What's my answer there? 2.226. Done. Log base 8 of 32. This will literally equal log of 32 over log of 8. Now, there's a big temptation sometimes for people to go, oh, isn't that the log of 4? No, it is not. It's log of 32 divided by the log of 8. What does that give you? Please. 1.66 repeating. Okay, and again, why do we use this? Think about it. If I had to solve this, this would be 8 to the y power equals 32, right? Okay. I could take this value right here, and I could turn this 8 into a 2 cubed, correct? And I could take this 32, right? And turn it into a 2 to the 6, right? To the 5th. You with me there? The bases would cancel, right? 3y equals 5, right? Divide by 3. Y equals 1.6 repeating. You feel me? So, some of you may look at this and just do it like I just did right now because you know that there's going to be nice, pretty bases. However, in D, like here, I've got log of 18 over the log of 4. If I try to do this the long way, 4 to the y equals 18. Can I break down 4 and 18 into equal bases? That's why we have a problem. That's when this formula, change of base, really helps. So what would this be? Log of 18 over log of 4. What is it? 2.85. Does that make sense, guys? Promise? Not that bad, right? All right. Tomorrow we learn equations and wrap this sucker up. Thank you very much. Hope you learned a lot.